Welcome to the control room. I'm Scott Bounds, a media cloud architect with Microsoft based in New York City. Today I'm coming to you from the Catskill Mountains in upstate New York. Today's webinar will be discussing rendering and visual effects using Azure. I will be joined by a couple colleagues of mine from Microsoft who are based in Pittsburgh and Los Angeles, a real example of remote production in today's environment. We have a jam-packed agenda, so let's get started. I'd like to kick off this webinar with a discussion about what we are hearing from our customers about rendering and visual effects workloads in Azure. I'd like to welcome to this episode Greg Denton and Anthony Howe, program managers with Azure Engineering. Greg recently joined Microsoft after years in the industry, and Anthony is a 10-year veteran of Microsoft. Hey guys, what are you hearing from our customers about their key concerns when looking at rendering and visual effects workloads?
Thanks, Scott. Yeah, so being new to Microsoft, I'm definitely interested to hear Anthony's perspective here. Some of the issues that I hear repeatedly from the industry are probably the biggest one is really just about ease of use and automation, being able to deploy quickly to the cloud and in a repeatable and reliable fashion, using tools like Terraform, things like that. So, Anthony, any thoughts?
Yeah, thank you, Greg, and thank you, Scott. So that is what we've been hearing from the customers. Definitely the ease of use, the automation, security is a big piece in the sense that the M&E industry is requires tight security and tight security standards. And as part of that automation, the Terraform can help describe the infrastructure so it makes it easy to get through the audits. So yes, exactly. We've been hearing those major areas.
Awesome. And what about autoscaling? How does Terraform really tie into that? What tools are available from Azure to be able to just quickly spin up a bunch of instances in a repeatable fashion?
Yeah. So For Azure, we have simple solutions all the way up to complex solutions. So for some of our customers that need to get up to, let's say, 40,000 cores, they actually will just use a VM skill set. And they'll run that VM skill set. All those machines will register into the render manager, and then they'll actually just scale that down themselves. Some of our other customers need more complexity, so they will use a solution like Azure Cycle Cloud. And Azure Cycle Cloud provides the necessary mechanisms for autoscale up and autoscale down based on integration with your render manager. So whether it's OpenQ or whether it's Traktor or any of the other popular render managers.
Cool. Does Traktor support that directly? Like, is there plugins available for it right now?
Yeah. So if you actually go visit the Cycle Cloud on their Azure Cycle Cloud GitHub site, you will actually see the Traktor plugins available right away there. So essentially, to get started along that track, if you wanted to integrate it, you would install the Cycle Cloud node, which is a controller node. And then in that node, you would install your plugin, which is and you can download that right off the GitHub site, and it's the Traktor plugin, and that'll hook in and watch the Traktor render manager database for new jobs. And as new jobs come in, and depending on how large they are, it will scale up to what's required to render them.
That's awesome. Very cool. So one other point that kind of ties into that autoscaling is around licensing. So I know one problem that comes up repeatedly is a studio has a set of licenses available on-prem, and that may be a fixed number of licenses, and they need to then either rent licenses or pay burst licensing fees in order to move to the cloud. It's a problem that I've seen at numerous studios, and I think it's just something that is a good opportunity for us at Azure to really come up with a good solution around. Do you have any thoughts?
Yeah, so Exactly. I think in Azure we're progressing to a good solution, but right now we have the two spectrums. So first is the customer can buy additional licenses to burst to Azure, and this requires them to really understand the load that they're going to run on Azure, how many machines are going to run on Azure, and then they buy that amount of licenses for that month. The alternative is on the other spectrum, we have in our Azure Batch rendering service, we do have licensing in there for Maya and 3ds Max, and essentially that's really good if you're going to do short renders. But if you go beyond 3 days in a month, it's more cost efficient to buy your monthly licenses and tie them into your license server. So some of our customers actually just stand up a separate license server for the cloud, and then they maintain that separate license server month by month, and it gives them a really clear picture on what they're using. But where we want to evolve is we want to evolve to something in the middle. Another trick actually customers have been doing is, and it's within the license agreements, is the licenses are per machine, and they can actually use some of our really dense SKUs. So we have some of the 96 core AMD machines. They can actually use that and make very efficient use of those licenses.
Cool. Yeah. So speaking of licensing and costs, another thing that comes up all the time is really around cost control and metrics, and being able to see what your spend is in as close to real time as possible, being able to analyze and ultimately really predict what your budget's going to be. There's so much work that goes into just trying to forecast what your workload's going to be ahead of time. And I know producers would love to be able to see more information, more dashboards around what their spend is, and how it's affecting their show budget. What does Azure have to offer in that area?
So actually, that's a really exciting area that's in the last year has really seen a lot of growth and innovation, and that's our Azure Cost Management, and that's come from we had acquired Cloudin a couple of years back. Microsoft had, and that got embedded in the portal, and then innovations on top of that over the last 2 years now. We have an API that we expose, and we have a whole Azure Cost Management infrastructure. So you can take all that data now. You as customers, you tag your renders and you tag your burst rendering per. You could tag it per scene. You can tag it per project, and then that all goes into the cost reporting database, and then you either query those APIs into your own cost reporting infrastructure, or you can actually use some of the new Power BI dashboards. And the Azure Cost Management team actually has a variety of templates now that really give you right out of the box. Give you very powerful views into your spend, and you can tell right away and catch unexpected spend that is really going to put up your bill.
Awesome. Yeah, the Power BI dashboards there, I can imagine, are super powerful and really helpful. So that's great to hear. Another area that has prevented a lot of studios from making effective use of the cloud, I think, is really around storage management also. So, no one wants to sit around and make sure that they're tracking file copies, from point A to point B, moving across different regions in the cloud, just uploading them to the cloud and pulling their files back down manually. It's a huge burden and has often been pretty error prone. I know with Azure, that workload is a lot simpler. Can you give me any details around what advances and what progress we've made there?
Yeah. So for the storage, an acquisition back in January 2nd of 2018, was the acquisition of Azure as a cache into the cloud. And the after the acquisition, again, there's been innovations from the Azure team, and there's a VFXT product that's on Azure and a managed product that takes that VFXT technology and turns it into a managed service called HPC Cache. And essentially, the VFXT and the HPC Cache run the Azure OS, and what the Azure OS enables is that cache in the cloud. So brings the data close to your running nodes in the cloud, and so there's only ever a single source of truth. So the nodes reach to the Azure for the data. The Azure, if it doesn't have it, goes back to on-prem. So what this enables is fast time to access that data, plus you never have these synchronization issues. So if you're running periodic synchronizations, you don't have race conditions on the data. You don't have stalled synchronizations because something happens with the synchronization tool. The Azure handles that all for you, and actually it makes it super easy to implement the burst rendering into the cloud. And we'll give a demo a little bit more later on some of the new technologies with the Azure that have been built on top.
Awesome. Yeah, that'll be super helpful. And just not having to manage all that data movement yourself and really have to worry about it is just a huge relief.
And one other additional thing that customers really like about that is when you do synchronize data, you then end up with two copies, and not only the single point of truth problem, but having the second copy becomes a security issue. So now they have to worry about this data that can potentially become an exfiltration problem. So having the Azure there, the Azure only brings up the data that it needs, and once all the rendering's done, you delete, like the Azure, it goes away and all that data goes away. So now you don't have that extra security point. So this is another advantage of the Azure, is you don't have to worry about a second data sync to secure.
Got it. And I imagine as productions are getting more and more spread worldwide and moving data between studios, being able to render, in separate regions to try to maximize your pipeline efficiency and costs and things like that. Being able to just spin up an Azure in a separate region and get to work rendering is a great benefit there too.
Yeah, exactly. Yeah.
So great. That's awesome to hear. All right. Well, thank you, Anthony and Scott.
Yeah. Thank you.
Now let's dig into the technical details of rendering on Azure. One of the first questions that we're asked is why Microsoft? Looking at the regional footprint of Azure in our hyperscale architecture, you can see why. Microsoft has 61 announced regions. These are across the US, Europe, and Asia, and also include one of our newest announced ones in New Zealand. This regional footprint gives the connectivity as well as the compute wherever customers need it. Also, Microsoft runs its own network. All of the regions are actually connected with fiber optics run by Microsoft. So we can really provide low latency and also fast transfers between regions as you look at your different workloads. Now let's welcome Anthony back and start to dig into some of these other questions. Anthony, what are the problems that customers are really trying to address?
Thank you, Scott. Yeah, so today I'm going to highlight one of the main problems that customers are facing. And customers are facing a problem of wanting to easily describe, manage, and deploy their on-demand infrastructure. And they want to be able to use the same tool as on-prem as in the cloud. So in our architecture diagram here, you can see the major components on-prem, which is their on-prem render farm, the network attached storage, and also the artists. And then in the cloud, the major components are going to be the express route, the gateway, the storage cache, and also the render farm. So customers come to us and say, we don't want to manually stand each of these pieces up. We want one solution to manage them all. And the solution that we've heard most about from the studios in the last year has been Terraform. The customers love Terraform. They love the fact that Terraform can describe all of the infrastructure in Azure. Plus, it can also help them describe their infrastructure on-prem and be able to have a single solution to manage across on-prem, Azure, and any other platform. Another thing on top of Terraform is its infrastructure as code. So this means that the Terraform can all be checked into your source repository, and now being part of that source repository can now be part of your DevOps pipeline. So a very popular technique that's being used that we're seeing more and more in the M&E industry is this notion of GitOps, which takes the DevOps concept one further and uses Git to manage your Terraform. So Git will take the will take the plan, and somebody will be able to approve the Terraform plan, and Git will then go deploy it on behalf of the user. So they really like that integration with the DevOps pipeline. It enables that agility, plus also enables auditing and a history tracking for security audits for when the security audits come by. Another thing that the Terraform enables is lowest total cost of operation. So with automation, you can scale up really quickly, scale down really quickly, and only pay for what you use. And which speaks to the on-demand running of services. So M&E rendering studios run on razor-thin margins, so you really want to always be turning off your infrastructure when not in use, saving that infrastructure costs. So Terraform has provided all of this. So based on this, we saw this signal last April start to appear from the studios, April 2019. And as we started hearing more and more, we said, okay, we're going to start building out the Azure Terraform, or we're going to build out the examples, providers, and modules to help burst rendering. And we're starting at the Azure piece. So I'll show you the Terraform site. So this is the Terraform site on GitHub. It's github.com/azure/Azure, and then you click on the Terraform piece, and it brings you into the examples, modules, and providers. So this provides different ways of setting up your infrastructure. It assumes different storage backends. You can see here NAS examples, like generic NAS filers, NetApp, Azure NetApp files, and I'll go through 4 examples on this website. So once we implemented this, we saw immediate adoption from the studios, and very positive customer feedback. Some of our customers who had never, their organization wanted them to use Terraform, and they had never used it before. They started using the examples, and within a day, they were running a full on-demand suite that they were able to spin up and then tear down. So it's really led to great customer engagement.
Anthony, one of the questions I hear from customers is, how do I migrate my on-prem investments to Azure?
One of my favorite examples is that's on our Terraform site is the backup, config, and restore of the Azure piece. So a lot of our customers running renders on-prem are running the Azure on-prem. And so the easiest way to get them started in the cloud is to run the config restore script that takes a snapshot of their Azure, and then using our Terraform provider, we automatically produce the Terraform template for HPC Cache and the Terraform template for the Azure VFXT on Azure. And this is really useful because they snapshot that. It then captures all their custom settings, all their core filers, and it captures everything that they've mounted. So then when they go to deploy it on Azure, as long as they have their express route and networking set up, everything mounts back just like it's running on-prem. So this gets them started along that path. Then they realize how easy it is to start render nodes, and they can import those into the cloud. There's mechanisms for importing the custom image into the cloud, and that gets them started along that road. And this is one of our examples off of our site.
Another question that we get is, how can we improve the remote artist workstation performance?
Yeah, so this was a very interesting need that came up in February and March, and that was the customer had came to us and they said, how do we improve our workstation's performance to our on-prem NAS filers? And so inside the Azure usually comes with this this read cache by default that accelerates your rendering, but there's also a mode in there called read write 30 with attribute checking, and also known as collaborating cloud workstation. And this mode is great for artists that are on the other side of the country or in other regions and need to overcome that latency back to the on-prem filer. So what one of our customers did was they set up this solution in Terraform, made it part of their DevOps pipeline. So when the artist comes in the morning, the infrastructure stands up, and they're able to use, which includes their workstations and includes the Azure. And at the end of the day, when the artist goes home, the whole thing turns off. So it was a really nice integration point, plus provided that nice performance for the artist during the day.
Anthony, a concern we've been hearing from our customers is about the costs associated with virtual machines as they wait for the cache to warm up. Do we have any solutions to address this?
Yeah, and what one of our customers came to us and said they want to save the most amount of VM time. So they had frustration over the VMs just sitting idle, waiting for the caches to warm. And so we said, we can help you with that by providing a cache warmer solution. So on our Terraform site, we have this cache warmer solution. It's integrated into the Terraform pipeline. And what it will do is, as the infrastructure is brought up, the Azure is brought up, the cache warmer you can submit a job to the cache warmer and submit the directories that you want to warm. And the cache warmer will proceed to start a VM skill set that will be massively parallel and pull all the files through up to the cache. And that VM skill set will run as a low priority. It'll run with OS ephemeral disks and be the lowest cost to warm that cache. As soon as that's complete, the VM skill set gets torn down and the Terraform job submission completes, allowing then the render nodes to start and then use that warm data so they're not sitting there idle waiting for that data. Now, one of the questions you may ask is, well, why can't the render nodes just have acted as the VM skill set that you brought up? And usually what happens is the render software usually opens the files serially, or if there is a bit of parallelism, it doesn't open it enough parallelism. So that's why the cache warmer does that maximum parallelism to pull the files through, and then when the render nodes do start, they get rendering right away, and the time to the first pixel output is super quick.
Now that my data is in Azure in a region, how can I actually use that across the global footprint we talked about earlier to render in multiple regions?
The Avere allows you to extend your data. It allows your data to reach into other regions. So, for example, it extends the reach of Azure NetApp files. So, for some customers who have rendering capacity in another region, or there's rendering capacity for them, there's SKUs in another region they want to use with their source data, like some of the AMD SKUs, they can keep that source data in the existing Azure region where it is, but then deploy the Avere into the destination region and reach across. And this solution here uses VPN gateway. VPN gateway is required for Azure NetApp files. You can also use VNet peering if you're using a solution different from Azure NetApp files. But again, to reinforce the advantage of Avere, it preserves that single point of truth. So no need to replicate data. The other cool example is the Avere hides latency. This is a real render demo. We're going to render 10 seconds of a scene. The compute power is in West US 2. And the source data is in the UK. And so we're going to render with 500 nodes. There's 10 seconds of frames. And you can see the latency is 130 milliseconds. And this shows the difference between using the Avere, which is the HPC cache that you see here, and you see the difference without the HPC cache. So you can see quite a time difference, more than twice as fast, and also the peak gigabyte per second is way higher. That's just because the data is close to the nodes. This leads to our third point, that it makes efficient use of the bandwidth, so that it's only pulling through the data once. And again, the Avere can be deployed in any region around Azure, any of those 61 regions that Scott showed earlier.
I'd like to welcome Greg back. Greg, can you give us some insight on OpenQ and other activities at the Academy Software Foundation around rendering?
Yeah, totally. Thanks. So OpenQ is a render management system that is entirely open source. It was originally developed at Sony ImageWorks, and about a year ago, it was made open source and brought into the Academy Software Foundation. As part of that, we've been continuing to build it out as an ASWF project, and we're continuing to add in more cloud functionality. It's really been gaining a lot of momentum and interest in the industry. And on the Azure side, I know we're really interested in tying it more into some of our products, being able to do things like we've talked about, being able to auto-scale and quickly deploy the whole environment, because it ends up being a fairly complicated setup sometimes. You have a central database server, you have multiple agents running both on-prem and in the cloud. You can have really complex hybrid deployments that need to be managed, and as well as just being able to make sure to deploy all of your other third-party apps with it and run it in a way that doesn't really feel like you're running the render farm on the cloud and a render farm local, but just a single central point to manage all of your rendering needs. So it's a really great project, and I believe Anthony is starting to look into some future work to help with ease of deployment around Terraform deployments to Azure.
Yeah, thank you, Greg. Just to add to our Terraform site that we showed in our previous demonstration, we built out part way of the infrastructure required for a burst render. So we are going to complete that. So you should keep checking back to the Terraform site, and we're going to have a full end-to-end deployment with Terraform that includes the OpenQ render manager, the UI piece to it, and then also tie in with being able to scale up a VM scale set. And then eventually further down the road, so we'll have the VM scale set piece there initially, because that's the simplest one to get going. We're going to tie in some of the Azure cost management that we talked about, and then we're going to go one level of complexity. This is the North Star, and that's getting the Azure Cycle Cloud in there so we can have true auto scale up and auto scale down. So stay tuned on the Terraform site. Thank you.
Very cool. That'll be great. Thank you, Anthony.
Anthony, can you give us a quick overview of all the resources that are available for customers interested in starting rendering on Azure for a POC or a pilot?
Yeah, so this page here shows a lot of the great resources we have available for you. To start off, we have our first render pilot, and then that'll show you how to get started quickly on Azure. The next is our Terraform site that we've talked about. We've showed 4 examples today, but it has 20 plus modules and examples on that site, and always continuing. So keep refreshing it. You're going to see more and more content on there. You're going to see our rendering white paper. It goes over those key areas that customers have talked about, why they need to move to the cloud. So based on cost management, based on security, based on ease of use, the rendering white paper touches upon that. And then also, we have a great article by Rick Shahid on the GitOps for Azure rendering. So this is that going into that, using your existing DevOps pipeline and making the rendering infrastructure, building out the rendering infrastructure as part of that. And we also have 2 case studies, one from Mr. X and one from Outpost, of their work on Azure. And finally, we have resources around HPC Cache. You can go learn about how you can use the managed service HPC Cache to deploy into the regions. And then also the Cycle Cloud, how you use that to scale your render nodes to hundreds of thousands of cores.
Anthony, after watching this webinar and reviewing the resources, what should be the next step for a customer interested in moving forward?
Great question. So I would say that the next step really is to dive into our first render pilot. And the first render pilot has 2 phases in it. And what we say to customers is, for your first 2 phases of jumping into rendering, keep it simple. So the phase 1 is get a single frame rendered on Azure. And it actually sounds simple, but there's actually a lot involved there. That's getting your network set up, getting your software on the custom image, and getting that custom image running in the cloud, and getting that registering into your render manager. So that's phase 1. Once you've ironed out those details, you're now ready to scale. And again, we say keep it simple. So what we say is use a VM scale set. And then from the VM scale set, also use the Azure cache, and then render a scene. And then that's the end of your phase 2. And our first render pilot document will go into that in more detail and the technologies involved to get you started.
Well, that's a wrap for this webinar. I hope you found all the information and demos and scripts very useful. Please provide us your feedback and comments. And also, please check out all the other webinars as part of the Control Room series. Thank you.